So here are 3 of the most popular smart thermostats on the market. And what we're going to be doing today is testing each one of these to see which one's the best. Because these manufacturers are stating that they can save you a lot of money on your heating and cooling bill, upwards of 20 to 30%. Not only that, they can also dramatically improve the indoor air comfort. But is any of that even true? And is there a chance that it's actually damaging your HVAC equipment? Well, that's what we're going to find out. So starting off, we have the Honeywell T9, and after that we have the Ecobee Premium, and from there we have the 4th generation Google Nest. We also have a bare bones on-off basic Honeywell thermostat that we're going to use as our baseline thermostat. We also are going to be using data loggers, one for each thermostat, and what it's going to do is track every 10 seconds the temperature and humidity levels. That way we can see, how well these thermostats are controlling the environment. We also have an amp and voltage meter. What this is going to allow us to do is take a look at the inrush current along with how much energy use the HVAC equipment is using. And we'll also be able to see what kind of wear and tear that these thermostats are putting on the equipment. So the way that we're going to conduct this test, it's going to be actually a 3-day test. The first test is we're going to get them installed, and what we're going to do is just let them run straight out of the box, basically on their factory settings, just to see how they operate right out of the box. So on day 2, we're going to reprogram these thermostats for the most ideal comfort, temperature, and humidity control. Day 3, we're going to flip these thermostats over to eco mode to see what kind of energy savings that these thermostats can pull off. So now let's go take a look at where we're going to be installing these thermostats. My loser sister thought these bright lights would make things more professional, and it ends up like we're just staring right into the sun. So here's our base thermostat. Let's go check out the other ones. Here's our front office here. You can see we do have a common wire and enough so it should be an easy install.
Yeah, so that's how the car was taken.
You can see here, this one does not have a common wire, so we're going to have to do some cool stuff. You can see here this one doesn't have a common wire either, so we're going to have to figure out which thermostats are going to work best where. So now let's go figure that out. Here's the Honeywell T9, and it is the most bulky out of the 3. Here's their room sensor, along with a common wire adapter, so when we're missing a common wire, this is what we use. Here's the Ecobee, and it actually looks pretty good. Their room sensor, they also have a common wire adapter as well. Here is the Nest thermostat, and it is the most sleek in their room sensor, and it does not come with a common wire adapter because it doesn't need one in order to work correctly. Okay, so here are the 4 zones in our office, and each zone is controlled by a different thermostat, and zone 2 and 3 are the 2 locations without a common wire. Zone 1 does have a common wire, and zone 4 we're leaving alone. So what I want to do is install the Ecobee in our front office section, and the Nest in our middle office section, and the Honeywell by our back offices. And again, zone 4 is going to have our control thermostat. So I'm going to install the Honeywell first, then I'm going to move over to the Nest, and then that's going to be followed by the Ecobee. Okay, so let's get this Honeywell installed, and don't need that. So this is a commercial building, and all 4 units are feeding the same common area, but the rooms that they feed are specific to that unit. So it's going to be interesting to see how they operate, especially in eco mode, because they might end up fighting each other. And if that ends up being too big of an issue, what I'll do is go ahead and install the room sensors for each unit and thermostat. That way we can set it up to have a more isolated test. So you can see that I actually have more than 4 thermostat wires here, but this being a commercial building, things get moved around all the time, because a lot of times each tenant will end up occupying the space differently from the previous tenant. And a lot of times the thermostat wires will get spliced up when things are getting moved around. So even though I have more than 4 wires here, I actually only have 4 good thermostat wires. So we still need to use that common wire adapter. So I generally view Honeywell thermostats as one of the more bulletproof thermostats on the market. So once you get them installed, you generally don't have a whole lot of issues with them. And the reason why I was wanting to install the Honeywell at this location is because of the power adapter. And by adding a power adapter, we are adding one additional thing that could potentially fail in the system. So I was wanting to use a Honeywell because of its robustness. So I made a mistake here by doing a close-up shot, and when I put the camera back, it did not autofocus. So this portion here is blurry. It did make my sister mad because she does all the fancy editing, but I don't care. Life is short and I didn't want to redo this clip. Now, if you've never installed one of these before, I could see how it would get fairly confusing. Now, as far as power adapters go, the Honeywell is the most confusing. The Ecobee and Nest are a little bit more color by number. So this portion took me around 6 to 7 minutes to install, so overall not too bad. Heck yeah, first try. Now, setting up this thermostat was fairly straightforward. The hardest part about all of this was just simply typing. And I think that's because I was a little offset when I was setting up the thermostat, and that's because the camera had the head-on view so you guys would get the clearest picture. Now let's get it connected to Wi-Fi, and you don't want to skip this step because initially I did, and you're not going to be able to connect your phone without Wi-Fi. From there, you can download the Honeywell app and get your phone connected. And getting the app set up and phone connected was actually fairly straightforward, and only took a few minutes. And if you don't want to wake up to a hot house in the middle of the night, you're going to want to change the settings to permanent hold. And this is the only setting that I've changed on this thermostat. And again, I am going to put this setting back so we can see how it performs right out of the box. Now let's install our data logger. And when it comes to temperature and humidity readings, it's going to be quite a bit more accurate than the thermostats because these are designed for the medical and food industries. And each one is tested and calibrated before they're shipped. And they also come with certifications. Okay, so one thermostat down. Now let's go get the 4th gen Nest setup. Now you probably notice here that I all of a sudden now have a common wire. And that's because when I did the initial walkthrough, we were actually in the process of replacing our carrier unit from 97 because the compressor failed. And when our guys were installing the unit, they were able to track down the common wire. So they wired up the thermostat to include it. And for a little bit extra B-roll, we decided to do a quick drop test. Pretty cool. And a quick business tip, if you're looking to rent out a space on a triple net lease, you're going to want to mark through your responsibilities to replace the HVAC systems when they fail. That's what we did because they're so old. And this is our 2nd unit that we've replaced. Free rent, heck yeah. Enough said, now let's get back to the Nest thermostat. The install itself was fairly straightforward and didn't take all that long. Now where I did run into some issues was getting it connected to my phone. That's because I have multiple Google accounts, personal and business, and flipping in between the 2 accounts was pretty much impossible for me. So what I figured out what you're supposed to do is delete everything off your phone, reset it to factory settings, download only the Google Chrome app, log into whichever account you want to use, set it to default, and you should be able to log in. I'm not really an app or software type person, but more of an equipment and hardware type guy. So that's probably why I was struggling some to get it set up. Now, if you are into technology, this is the thermostat for you because it has all the features, widgets, and whatnot. However, if you're not into technology, I would probably stay away from it because we get the most service calls on Nest thermostats because if somebody gets up in the middle of the night to adjust the temperature and accidentally changes a setting, it can start doing all these crazy things and it can be difficult to get the settings back the way they used to be. However, if you are good at navigating tech, unlike me, you should not have that issue. Now let's go ahead and mount our data logger. Now let's move over to the Ecobee thermostat and get it installed and set up. So I am a lot more familiar with this thermostat because we use a version of this one when we install a 2-stage Performance Series carrier system. And the biggest difference is the one that we use comes with IntelliSense. And if a customer prefers a different smart thermostat, and it usually doesn't change the price because smart thermostats usually cost all about the same. Okay, so quick disclaimer. This is not a how-to video because I am cutting some corners to help speed things up because I'm doing things like not turning off the furnace breaker. So there is still 24 volts going through the thermostat wire, which could give you a little shock. And if you touch the ends of the wires together, it could fry your furnace control board. So I'm sure there are some better how-to videos out there. I'm really a lot more interested in the overall performance of these thermostats, along with how they compare. Now, being in the HVAC industry, there's really not any money to be made when it comes to thermostats. So I don't have a dog in the fight, and I honestly don't care if one's better than the other. Now, what I do care about, if you're located in Texas and in our service area, when it comes time to replace your HVAC system, that you give us an opportunity to earn your business. I'm not asking for a handout, I'm just asking for an opportunity. And if you're outside of our service area, you can really help me out by liking, subscribing, and leaving a comment. This will help with the algorithms. So some of the issues that we've had with these thermostats is the temperature wouldn't be calibrated correctly. For example, if the temperature was set on 72, but the actual temperature was 78. It doesn't happen very often, but it does happen. And every now and then we'll also find a bad one out of the box. Other than that, customers generally like them. This one took about as long to install and hook up to my phone as the Honeywell did, so pretty easy. Let's get the data logger going. Now, last thing to do is set up our last data logger for our basic thermostat. So after 1 day of testing, here are our readings. So this first square here is the Ecobee. This next square over here is the Nest Gen 4. The bottom left is our Honeywell. And the bottom right is our basic thermostat. As we're looking at this chart, these green lines here are our humidity levels. And this orange line here is our temperature. And on the left of our graph is our temperature in Fahrenheit, starting with 90 degrees going all the way down to 60. And on our right hand side is our humidity levels, which is starting at 70% going down to 40%. And at the very bottom, you can see that we started the test at 3 p.m. and we ended it at 3 p.m. And this blue section here is when our office is not occupied. So let's first take a look at the temperatures, or the orange lines, and you can see that the Ecobee ran all the way up until around 11:30, and then it went into sleep mode, which was set at 75 degrees, and somebody came in at 6 o'clock, and then that's when the system fired back up, and then it ran continuously from there. And when it comes to the Nest, you can see that when we left the building, it almost immediately went off and went into sleep mode. And once again, when somebody entered the building, it fired back up. The factory settings on the Honeywell had it scheduled to go up to 82 degrees at 6 p.m. And at 6 a.m., somebody had to manually come in and turn it back on. And our basic thermostat ran all night wide open, and that's largely because these 3 units are off. So you can see that the areas in red are the common areas in our office, and all 4 systems feed this area. So the temperatures in this area are all going to raise and lower together. So if we have 3 systems that are off and only 1 that is running, it's going to run all the time trying to satisfy the temperature in this entire area. And is going to create a lot of bleed over, and that's what we're seeing on our data loggers. And that this first test is basically junk and needs to be redone. That's why you see me setting up the sensors to see if we can isolate a specific room and solve this problem. And as a side note, going back to the front office, these green lines here representing humidity is too high, because anything above 60% humidity levels is considered uncomfortable. And what's interesting about this test is as the unit is running, the humidity levels are going up. And when it's off, the humidity levels are dropping. Now, there are a lot of different things that could be causing high humidity. And since this is a commercial building, my first thoughts are there's probably something going on with the fresh air. So this pipe here is the fresh air intake, which is pulling outdoor air into the unit. So I should be able to tighten down the damper to reduce the amount of fresh air coming into the unit. So when I crawled all the way to the front unit, I found that the damper was completely broken. So we're getting 80% humidity outdoor air being dumped into the unit, which is driving up the humidity. And to fix this, it's just going to have to be a project for another day. Now, backtracking to the Honeywell sensor, installing it was pretty straightforward and only took around 7 minutes. And when it comes to the Google Nest, it was also fairly straightforward other than verifying my account again. So it took 15 to 20 minutes to install and set up, which was a little frustrating because it should only take about half that amount of time. And that was largely due to the account verification. The Ecobee was also pretty straightforward, taking only about 5 to 7 minutes to get set up. I'm also setting up the thermostats to prioritize the room sensors and to ignore the thermostat readings. This should solve the problem that we were dealing with in regards to the common areas all feeding into each other. This should make everything a lot more isolated, so we get a lot more accurate data. So now we're going from this to this. And as long as we keep the doors closed as much as possible, we should be good. Okay, so now you can see that the second day of data logging is complete. And the nice thing is the data is a whole lot clearer this go. You can tell that we don't have the same bleed over as what we had earlier. Because you can see that both the orange and the green lines, how they're cycling rapidly, and how there's not a big delta in between the cycle times of the HVAC equipment, and how the temperature peaks and troughs aren't that big. That's because all the units are feeding into each other. And if you look over here, that is no longer the case, so we got it isolated. Success. So we should have a lot better idea of how these thermostats behave. And as a quick side note for the basic thermostat, I did leave everything set up in the common area just to see what's going on. So it's not really good data for comparison. So we're going to leave that one alone and focus on the other 3 thermostats. So the only adjustment that I made from the factory settings for all 3 thermostats was to turn it on cool and set it at 72 degrees. And from there, I made no other changes. So we can see that the Ecobee did pretty much the same thing as the day before. So what's going on the right-hand side of the screen is the Ecobee's thermostat report, showing us the thermostat set points. So you can see that it did average around 72 degrees until 11:30. Then after that, it went into sleep or away mode or whatever mode it went into and jumped up to 75 degrees. Then came back on at 72 degrees when the first person entered the office at 6 a.m. And when it is operating, you can see that the thermostat is triggered at 74 degrees and cools down to 70 degrees, which is a 4-degree split, and that's going to be an important point here pretty quick. So now let's jump over to the Google Nest thermostat. And again, all I did to the thermostat was switch it to cool mode, set it at 72 degrees, prioritize the room sensor, and that was it.
And on the right, you can see the Google Nest Energy Report showing us when the equipment is running. So you can see that the HVAC system ran all the way up until around 8 p.m. Then it shut off from there. Temperatures got upwards to around 76 degrees. It fired up a little after midnight and ran for about 2 hours straight, with the temperature going as low as 67 degrees. And I'm not really sure why it did this, because nobody was in the office. So I don't know if it's just simply learning and just trying to get ahead of the hot day, or maybe it's thinking that the energy prices are cheaper at night. I don't really know. It doesn't make a whole lot of sense to me, because that is a 10-degree swing in the temperature. Then from there, it cycled on and off throughout the rest of the day. So there's a couple things that I want to point out real quick. So we can see that it is operating in between a 3 to 4 degree split by the time it's cycling on and off. And this trajectory right here is pretty interesting to me, because you can see it was averaging around 69 degrees in this area. And close to 3 p.m., you can see that the average temperature did increase in between 72 and 73 degrees, which is a 3 to 4 degree increase throughout the day. And this is going to remove some of the load on the HVAC system, which I kind of like. And the last thing I want to point out is the run times. It's pretty common for this to turn on for a full hour at a time, then turn back off for about a full hour. And if you look at the Ecobee over here, it's able to turn on, satisfy the room, and turn right back off. So what that's telling me is we either have an undersized unit, which I know is not the case. So that would mean that we have airflow issues in this room. So I'm just trying to point out that the long run times is not the fault of the Nest thermostat. Now let's jump over to our Honeywell thermostat. Once again, all I did was set it to cool mode, lower the temperature to 72 degrees, then prioritize the room sensor. And no other changes were made. On the right, I have our Honeywell runtime report, which is super basic, and there's also a 2-day lag before you can get a hold of this report. So you can see around 3 p.m. I prioritized the room sensor, and that's why we see the temperatures drop from 76 degrees all the way down to 71. And at 6 p.m., the thermostat was scheduled to raise the temperature to 85 degrees. And at 6 a.m., when somebody came in, they had to manually lower the temperature back down to 72 degrees. And around 9 o'clock, the thermostat raised the temperature back up to 85 degrees, and we had to manually turn it back down. So this thermostat is not designed to use right out of the box without changing the schedule, which in all fairness is pretty easy to do. And the most notable thing that I see on this chart is that this thermostat is operating off of a 2-degree split. The HVAC equipment is going to cycle on and off a lot more frequently than if you had something like a 4-degree split. So I'm talking a lot about cycle times, so let me show y'all why that's important. Okay, let's head over to our 4-ton unit that we use for training. Let's pop off the panel and hook up our multimeter tool, fire up the unit, and take a look at the inrush current. You can see that the inrush current was almost 113 amps. So we have 113 amps slamming into the unit in under a second. And if you don't know much about electricity and you're asking, is that a lot? The answer is yes, that's a lot. Now I'm looking at the operational amps after the system's fired up, and you can see that it's running around 15 amps. So now it's kind of coasting. The bulk of the power usage is coming from the compressor, which I'm going to show you now. Basically what's happening here would be tantamount to having a car, and every time you come to a stoplight and it turns green, you just punch it until it gets up to speed. And let's say you had 2 routes going to work, one with twice as many stoplights than the other. The one with twice as many stops is going to put a lot more wear and tear on your vehicle. That's pretty much the same thing that's happening here. On the left of the screen, I'm going to go ahead and measure the inrush current and running amps on the furnace. I'm doing it mostly for B-roll. It doesn't contribute all that much to the video, so I'm not going to get into it. Okay, back to our charts. What I'm really interested in looking at here is the peaks and troughs, not so much how often the units are firing up. And that's because all of these have a slightly different heat load and HVAC design. And as we all know, the Ecobee is running a 40-degree split, and the Google Nest is running in between a 3 to 4 degree split, and the Honeywell a 2-degree split. So a 4-degree split is going to be a whole lot easier on an HVAC system. So if you're looking for longevity for your HVAC system, the Ecobee is the best. After that is the Nest, and the Honeywell, not so much. So if you were thinking that there is no way for me to draw any meaningful conclusion after just a few days of testing, you would be right. This 3-day test ended up turning into more like a 2-week test. Let me show you why. Here's the end results when it came to the best thermostat for comfort, which took some work to get here. So all 4 of these is for the Ecobee trying to get to the best comfort settings. Day 1, all I did was set a temperature hold at 72 degrees. I left all other settings alone, like the schedule and eco mode, like it came from the factory. And apparently once you add a hold, that means the thermostat could do whatever it wants. Right here, it's telling me that eco mode is active, which I'll get into later once we get to the savings section of the video. So it appears that eco mode is overriding the temperature hold, so I turned it off. And went ahead and turned on overcool mode, which is supposed to help with things like humidity. So I set it to just a half a degree, so nothing too crazy. And holy cow, look at these humidity levels drop. But actually, overcool didn't have anything to do with it. We actually had a little cool front that came through and lowered humidity levels to like 20%. So now the system was pulling in 20% humidity from outside, which was dramatically lowering the humidity levels. and shortly after you can see humidity levels go back up as the humidity levels increased outside. So at the end of the day, I'm not going to really be able to test the thermostats to see if they can improve humidity levels. Now I can tell that eco mode is off because the system is cycling longer throughout the day. However, at 11:30, it increased the temperatures to 75, 76 degrees, which matches the sleep schedule. And that's because this guy here found something new and shiny, messed with the thermostats, and removed the hold. And right here, this is when the folks up front went to lunch, and I decided to freeze them out. And from there, I gave up on temperature hold and went into the schedule and changed everything to 72 degrees. That way, if somebody ends up playing with it, it will always revert back to its schedule. I also turned off overcool mode because we're not going to be able to solve the humidity question with this HVAC setup. And that worked because now it's running all night. And from there, I wanted to lower the on-off temperature swings to give me a more consistent temperature, kind of like the Honeywell thermostat. And that will help with things like hot and cold spots and overall a more consistent temperature. So I lowered the temperature cool difference to 0.5 degrees to see if we can get the system to cycle more often. So we were able to get the system to cycle a little more often, and the temperature delta does look like it dropped by like a degree. So overall, not as dramatic as what I was hoping for. Now let's jump over to our Nest thermostat. So I'm going to do the same thing as the Ecobee. I'm going to set a hold for 72 degrees and leave all the other settings alone. So I guess whenever you set a hold on a smart thermostat, that just means hold my beer and watch this. So it's clear that these thermostats will prioritize eco mode, so I turned it off. From there, I went and turned on humidity helper just for fun. And yes, this thermostat was also messed with by the same guy, who is my dork brother. I don't really have any words when it comes to the results. All I know is my brother owes the people in that office an apology because that looks miserable. So I turned off humidity helper, set everything on the schedule for 72 degrees, and that worked. So you can see that it did cycle after everybody left around 9 o'clock. So we're for sure out of eco mode. Since this is the middle office and it only has one exterior wall, it has the smallest heat load out of all three zones. That's partially the reason why we don't see it cycling all that much during the night. To fix this, I changed the temperature swing settings to 2 degrees, and now it runs all night, as you can see here, which is now way more ideal for comfort. Now, let's take a look at our Honeywell thermostat. All I did was have the thermostat set at 72 degrees and place it on a permanent hold, and it worked. And I just let it run for 3 days because there really wasn't anything to tinker with, like any fancy humidity setting or temperature swing. So as I was messing with the other thermostats, I just let this one run. And after day 3, I quit recording data because I had pretty much everything I needed. And the only thing that stands out is how this temperature here is creeping up. And at nighttime, it's running around 70 degrees, even though I had the thermostat set at 72, which is a plus in my book. So here we have all three thermostats side by side. So what I'm looking for here is how often the equipment is cycling. What is the delta in between the temperatures turning off and back on, along with how well it holds the temperature throughout the day. So if we take a look at our temperature swings and temperature delta, you can see that the Nest and Honeywell thermostats are running around a 2 degree temperature swing and are cycling quite a bit. And our Ecobee is running closer to a 3 to 4 degree split, which was a slight improvement over the factory settings. And for temperature consistency, you can see that the Ecobee and Nest thermostats don't budge at all throughout the day, while every single day of testing the Honeywell, it did fluctuate some. Not anything major, but it was there. So the Ecobee did perform the worst out of these three thermostats, and that's because the on-off temperature swings is the biggest out of the three thermostats, and that can create a little less temperature consistency, along with some hot and cold spots. And if I was speculating here, I would think that some of that would be due to them having partnerships with some manufacturers, like Carrier. And if you're operating a single-stage system on a 2 degree split, it's obviously going to make the system cycle on and off a lot more frequently, which will wear out the equipment faster. And no manufacturer would look at this graph for the Honeywell and Nest and say, oh, that's good for the equipment. Now, when it comes to the Nest, putting it in a box and making it do exactly what I wanted to do was about as easy as giving a wildcat a bath. Because if you think about it, it's a learning thermostat with algorithms and probably AI that's going to take over the world, because it's designed first and foremost to be eco-friendly and make its own adjustments. And I can tell over the course of working with this thermostat, it's doing everything it can to get back into eco mode or learning your schedule. So keeping it in the box that I put it in is not something that it's designed for, because if you look at it wrong, it will go back into eco mode or start doing all this weird stuff. And for that one reason, I'm putting it at number 2 on this list. And the Honeywell is going to be your best bet for comfort, because you really don't have to change anything right out of the box. All you have to do is turn on a permanent hold or set up your schedule, and you're off to the races. And the temperature fluctuations really aren't all that bad, because you can see that it stays well below 72 degrees throughout the day. And at nighttime, it gets down to around 69 degrees, which is pretty sweet because you don't have to adjust the temperatures before bed. So now let's take a look at savings or eco modes. Here are the final results that we'll get to in a second. So I'm going to go back through each thermostat and reset it to the original settings, turn on their eco settings and see what they do. And one thing to note here is I'm not letting any of these apps track my phone because I don't like it when companies try to exploit my data and do things like sell it to somebody else. So knowing whether or not these spaces are occupied is going to have to come from the thermostat or room sensors. Here's 3 days of data for our Ecobee. The first graph here I'm reusing from the comfort section. It's the one I put a hold on the thermostat without making any changes, and apparently it went into eco mode. And the next graph is a Sunday, with the office being vacant that day. And the last one was that next Monday. And the biggest thing to note are these sections here, because the schedule is set to run until 11:30, then go into sleep mode, which is set at 76 degrees. You can see that it's not maintaining 72 degrees until 11:30. So when there's no occupants, the temperature is adjusting back up to 76 degrees. And over here is a Sunday. So you can see that it basically maintains 76 degrees throughout the entire day. I also have away mode set at 82 degrees, so I'm not really sure why it's maintaining around 76 degrees. Now let's take a look at the results for our Nest thermostat, and this is the exact same setup as the Ecobee. The first chart is the one from earlier where I added the hold on the thermostat. The second one was recording over a Sunday, and the last one was that next Monday. And the results are a little like the Ecobee. I did have the schedule set for 72 degrees for comfort, which it pretty much never ran at. And you can see it would raise the temperatures up to 76, 77 degrees, even when the office was occupied. And on the weekend, it only cycled 2 times. And the reason for that is it's clear that somebody left the door open because the green line showing humidity is going up and down, showing me that other units are cycling and the air from the common area is making its way into that room. And when it comes to the Honeywell, there's just not much to see here because it doesn't have an eco mode. It runs primarily off of its schedule. And you have to geofence your location with the thermostat for away mode to work, which I didn't do. So we're just looking at a thermostat operating off of its schedule. So really at the end of the day, we're only comparing the Ecobee and the Nest. So let's do a side-by-side comparison in between the Ecobee and Nest thermostat. So the biggest differences in between these two thermostats is when a room is no longer occupied, the Ecobee will turn off 2 hours after there's no occupants, because here you can see when everybody left, and the person at the front office doesn't open it up until 7, which you can see here, and it immediately fired back up. And when the room was occupied, it maintained an average of 72 degrees. And even with the room not occupied, it would still cycle some, like you see here. And when it comes to the Nest thermostat, this office is occupied at 6 a.m. and everybody leaves at 6 p.m. And it's allowing the temperatures to run up around 76, 77 degrees even while it's occupied. And it doesn't cycle at all when it's unoccupied, unlike the Ecobee. And even though I had the occupied temperature set at 72 degrees, it's averaging around 73, 74 degrees. So when it comes to energy savings, it does look like the Nest is the best because it's doing everything it can not to run the HVAC system. Now, if you're really interested in running your HVAC system environmentally friendly, the Nest has you covered there too. Because I've been on a lot of conference calls with various manufacturers trying to answer this question about sustainability. And my opinion on this has always been the HVAC system on a home consumes 40 to 50% of the energy consumption of the house. And the only way to solve this is to rip out your HVAC system and not use it. Now, the next best solution is this Eco Hold on the Nest thermostat because it locks the temperature at 82 degrees, pretty much to make sure nobody dies of heat stroke. I did try to run a test for you guys, and Phyllis and Abby, our CSRs, were not having it. And they're some of the most important people in the office because without them, everything grinds to a halt. And the test quickly came to an end.
So before we jump into our summary and conclusion, I do want to mention one thing that might benefit you some. Here at Atlas AC, we are a very transparent company. So if you ever have any HVAC needs, you might want to check out our website where we have free buyer's guides, price lists, and other YouTube videos even. There are hundreds of thousands of folks all over the United States that use those tools to help get educated about HVAC. And the reason why we're doing this is because we're doing our best to change the industry for the better and to shed as much light as we possibly can on it. Now that that's out of the way, let's go ahead and talk about our 3 thermostats. Now, unfortunately, I wasn't able to test our bare bones thermostat, which is not here right now, and that's because it was located in a common area of the office, and there's no way for me to isolate it to test it and compare it to these. And also, I wasn't able to test these thermostats to see how good they were at humidity control. And that's largely due to our HVAC systems having, fresh air intake. So the outside air and humidity levels were throwing off our data. So we'll track that down in another video another day. So over the course of the last 14 days of our 3-day test, we ended up learning quite a bit about these thermostats. In the Honeywell here, the factory schedule is set up for like 82, 83 degrees. So once it's installed and you turn down the temperature to, let's say, 72 degrees, it's always going to revert back to those higher temperatures and you could end up waking up in a hot house. Now these two, they did function very similar to each other. And it appeared to me that you really couldn't get yourself into too much trouble because, the schedule would raise up to around 75, 76 degrees, which, isn't life or death. Now, when it comes to the usability of these 3 thermostats, the Honeywell was by far the easiest one to use. You can kind of just set up the schedule and you're done. Then after that, the next easiest one to use was the Ecobee. And the Nest thermostat does have the most going on with it. Now when it comes to comfort, things like temperature swings, hot and cold spots, the Honeywell did do the best out of the three. And that's because the delta on when it turns off and back on is only about 2 degrees. That means it's cycling on and off a whole lot more often, which is going to help with temperature consistency. And the Nest was the runner-up. You just have to stay on top of your settings and make sure that it doesn't go back into eco mode or something like that. And the last on this list is the Ecobee thermostat. And the reason for that is the on-off temperature delta did range in between 4 to 5 degrees. So you're going to end up with higher temperature swings and a little bit less consistent temperature. That being said, there's only so much you can do with a single stage HVAC system, which is your bare bones, budget friendly AC system. So trying to increase the comfort of a home using entry level equipment, there's just not a whole lot you can do. And there's only so much that these thermostats can, do to improve that situation. And you really need like a multi-stage or variable speed system. Now, if you want to learn more about single stage versus 2-stage versus a fully variable system, I do have other videos that you can check out after this one. Now, that being said, the Honeywell is the best for comfort, but the problem is since it only has a 2-degree temperature swing by the time it turns on and back off again and then on and off, so it will be adding more wear and tear on the HVAC equipment. And since the Ecobee has the largest temperature swing difference, 4 to 5 degrees, it's going to end up being the easiest on the equipment and a little more ideal for longevity. And the Nest is most likely going to fall somewhere in between. Now, when it comes to energy savings, it does appear that the Google Nest is the best out of the three, because when it's in learning and eco mode, it is trying to figure out different ways to not run the equipment as much as possible. Now, the Ecobee does have an eco setting and is our runner-up, and it does appear that the algorithms on this one is a little bit more linear, and when it comes to the Google Nest, it appears to be a whole lot more, dynamic. And when it comes to the Honeywell thermostat, it doesn't have an eco mode. Now you can prioritize things like when a space is occupied and unoccupied, and if it's unoccupied, if you want it to go into away mode and that kind of stuff. But it's clearly, to me, not really a smart thermostat, especially when you compare it to these two. And when it comes to energy savings, I do have a hypothesis on it about how if you're trying to prioritize energy savings and then along with having good comfort at home, for instance, if you're at home and you want the temperature set at 72 degrees, and when you leave to work, you have the temperatures go up to, let's say, 82 degrees, and when you come home, the system fires back up, and then it cools the house back down to the way you like it. Or you have it preset to do that an hour before you get home. Well, the problem with that is the first law of thermodynamics. Energy can't be created or destroyed. So when you heat up a home to 82 degrees, that's going to warm up the foundation, the ceiling, the furniture, and just everything in your house. So when the AC kicks on and brings the temperature back down to 72 degrees, everything else is still 82 degrees and ends up acting like little heaters. So the HVAC equipment is going to be cycling on and off more often until everything in your house gets down to 72 degrees. So is it really saving you energy or not? Well, that's going to be another test that I'm going to be doing. Now, circling back up on these thermostats, the Honeywell was best for comfort. The Google Nest appears to be the best for energy savings. And the Ecobee is going to be the easiest on your HVAC equipment. I hope you enjoyed this video. Till next time, have a good one.
We're going to be testing this mic also because you may have to redo the beginning. Take the mic, put it on, let's go. All right.
Wait, I'm not redoing the beginning. So what do I say?
Closing. We've practiced this.
Test?
Don't act like it's there.
Test.
Act normal. Put your hands down.